Hey everyone, so today we're going to do 6.3 systems of linear equations, but this time we're going to do it with augmented matrices. So in the previous two sections, we were solving linear equations with substitution and elimination, or the combination of two. We're still going to do that, but we're going to do it using matrices. And what we're actually going to do is look at this form that is either called upper triangle form or triangle form. Okay, well, why is that? Well, if you look at this matrix, or not matrix, but look at this formatting of the equations right here, this allows us to find the solution very easily, because right here in the bottom, the last equation here, we have z equals -1. Well, if we know z is -1, then we can substitute in and solve for y. And then if we have y, we can then substitute in the top equation for y and z and find x. One of the things why this is called the triangle form, and yes, it's obvious to see that, hey, there's a triangle right there, but really, if we were to fill in the rest of these, we would have zeros as triangles here. And I also want you to know one other thing. Look at your x, y, and z. They're all 1x, 1y, and 1z. So that is our goal when we do this triangle form. So the first thing we're going to do is we're going to write this in an augmented matrix. What does that mean? Well, that means we're actually going to make sure that all the x's, y's, z's, and then what they equal are all in the same column, and then we're going to get rid of the variables so they don't get in our way. So you need to make sure your x, y, z in order. So when I make my matrix, I have 3, -1, 1, and then usually when there's that equal sign, they have a line down here. And put 3. 2, -4, 3, 16. 1, -1, 1, and 5. As you can see, your first mistake could be forgetting a negative. So don't do that. Make sure all your numbers line up. Okay, otherwise you do a lot of work for nothing. So when we do this now, there are a couple moves that will help us make this triangle formation, okay? The first thing is interchanging the position of any two equations. What does that mean? I'm going to switch the rows around to make it easier on myself. The other one is replace the equation with a non-zero multiple of itself. So that's what we were multiplying an equation by 2, so that way we can then eliminate it with another equation. Make sense? So this is what I want you to do when you format stuff. First of all, anytime we do a rule or something, we're going to write down exactly what we did, so we know what's happening. We also might do some side work to allow us to get to the math easier. Okay, I'm hoping I didn't make my space too little, but we'll see how this goes. So remember, one of the things that we can do is interchange the position of two equations. Now remember, our goal was to have ones in the diagonal position and zeros on the other 3 in this corner, right? Well, one of the things that helps you with this is always start with the top. So see how we have 3 there? Is there a way that I can make a 1 in that position easier than anything else? So 3 right there. How can I make that a 1? I can switch row 1 and row 3. So that's what I'm going to do now. Switch, and I'm going to write it down. Row 1 and row 3. Okay, so now I'm going to make my new matrix. I have 1, -1, 1, 5. I still have 2, -4, 3, 16. And then I have 3, -1, 1, 3. All right. That's good. We've got that one all set. This row is fine. Now we're going to go to the next row. In this position, I want a 0. how could I make that a 0? Well, we can multiply and eliminate. And if you look, the easiest thing to multiply would be this row. Now, by the way, every step we take now, this is our new row 1, row 2, row 3. So anytime I say row 1, it goes back to the matrix that they just came from, not this one. So if you see right now, what I can do, and I'm going to move my arrow down here, I'm going to take row 2, because that's the one I want, and I'm going to subtract 2 of row 1, because then I can eliminate it. Okay, so watch. I have 2, -4, 3, 16. Now I'm going to multiply row 1 by 2. I get 2, -2, 2, 10. Now remember what I'm going to do with it? I'm going to subtract it. So I get 0, -4 minus -2 is -2. 3 minus 2 is 1, and 16 minus 10 is 6. Okay, so now I'm going to rewrite this and say, remember that row 1 stays, so that should be positive, 1, -1, 1, 5. Now my new row 2 is this, 0, -2, 1, 6, and I still have 3, -1, 1, 3. Okay. Now, what else can I do? Well, I also need to make this 3 a 0. How could I do that? Well, I can take that row 3 and subtract 3 of row 1. So 3, oh, you guys can't see that, can you? There we go. 3, -1, 1, 3. And remember, I'm going to multiply this by 3. So I get 3, -3, 3, 15. I'm going to subtract straight down. I get 0. -1 minus -3 is 2. 1 minus -3 is -2. And 3 minus 15 is -12. Guys, if you like addition a lot better, just multiply by the negative number and add straight down. All right, so this new matrix. 1, -1, 1, 5, 0, -2, 1, 6. And now my new row 3 is 0, 2, -2, -12. So far, so good. We've got that first column down, right? Okay, next, what do? Well, first thing we need now is we need this right here, right, to be what value? We need it to be 1. How can we get this to be 1? Well, to get it to be 1, we can divide by -2. So what we're going to do here is take row 2, and what we're going to do is multiply by -1/2. I know I said divide by 2, but usually we use multiplication when we use matrices, so we're going to stick with that. So we're going to multiply row 2 by -1/2. So we can get 1, -1, 1, 5, 0. That becomes 1. That becomes -1/2. And that becomes -3. Okay, the bottom row is still 0, 2, -2, -12. Now, why did I have to do the -2 first? Well, I guess in a way I could have added these two rows to get row 3 to be 0 first, but I didn't look ahead. What I was looking for is that if I can change that to 1, then I can manipulate it like I did these other two. Okay, so I need to get this to be 0. So what I'm going to do is I'm going to take row 3 and I'm going to subtract I'm going to subtract 2 of row 2 because I need to double it to make it work. All right, looks like I'm running room workspace, huh? I just want to make sure this comes out right. Okay, ready? So I have my row 3, which is 0, 2, -2, -12. And I have to multiply by 2 here, right? So I get 0, 2, -1, and -6. And I'm going to subtract straight down 0, 0, 1. Subtract straight down, I get -6. Oh, and this should be -1, right? Sorry, you guys see my math? So took row 3, subtracted 2 of row 2. Now I get 1, -1, 1, 5, 0, 1, -1/2, -3. And my new row 3 is 0, 0, -1, -6. We are so close, guys, aren't we? What's left? What needs to be there? What's wrong with this so far? That needs to be +1. So what do? We multiply it by a -1 to R3. So our final matrix is 1, -1, 1, 5, 0, 1, -1/2, -3, 0, 0, 1, 6. Awesome. So what does that mean? Well, first of all, that means that Z is 6, right? That means I can say 1y minus 1/2 of 6 equals -3. And then when I solve for this, right, I get y equals 0. Now I can plug both of those back in here, so I get 1x minus 1 times 0 plus 6, or 1 times 6, equals 5. And when we solve for this, let's see, -1, x equals -1. So our answer is, and I know I'm running out of space, -1,06. So we did what we did in 6.2, but it's just a little bit more organized, okay? All right, now, oh, I'm losing my papers, guys. What am I doing to myself? All right, next page. All right, so that was the triangle form, right? Well, the new form that we can do here, the row echelon form, is almost like the triangle form. But the truth is, what happens is we're going to make it so we have 1 through the diagonal and then 0 on the other sides, on both the triangles there. Because what happens there is it gives us our exact solution. All right, so we need to use the row echelon form because what happens here is the first non-zero entry in every row is 1. So that's where you get your diagonal, okay? The leading one of the given row must be to the right of the leading row above it. So again, that diagonal. Any row of all zeros cannot be placed above a row with a non-zero. So all zeros down below, okay? So the following matrices are in row echelon form. The third matrix is in what we refer to as reduced, okay? Now, when we get the reduced, what happens, guys, is this is our solution. Now we don't have to substitute back in for anything. In this case, our x is 2, our y is 3, and our 1 is 4. So the reduced echelon form is really good. Okay, so below are not in form. As you can see here, this is not in that form because zeros are on top. Here we have a 1 before the other one in the row below it. Here we don't have 1s in the diagonal, okay? So we're going to use some of the same rules to allow us to put them in the reduced echelon form. I want to make sure that that's what I want to do. Okay, well, let's go from there. Let's see what happens with it. Okay, so first thing we're going to do is put ourselves in a matrix, right? An augmented matrix. So we have 2, 3, put our line there, 6. We have x. And why am I doing that? I do that every time, don't I? 1, no variables. -1 and 1/2. All right, so what's the first thing we might want to do? Well, we need the x to be 1 in that upper left-hand corner, so why don't we switch row 1 and row 2? -1, 6, 2, 3, and of course I did that. And these are mistakes you guys are going to make. That's why I don't mind making them right now. Okay? Don't forget to switch the whole row, not just missing it. Okay? Sorry, I got hair in my mouth. So by the way, with this, guys, you might want to keep in mind that since it doesn't say reduced form, we're not going to go all the way. We'll just make sure that diagonal's right there, right? All right, so we need a 0 in this spot, so what can we do with it? Well, we can take that row 2, and we can subtract 2 of row 1, right? Because that would work there. I'm going to create my workspace. So I have 2, 3, 6. I'm going to multiply that row 1 by 2. So 2, -2, 1. And I'm going to subtract it straight down. I get 0. And then I get 5, 5. All right, so 1, -1, 1/2. Now my new row 2 is 0, 5, and 5. Okay. Now what's my next step? Oh, and then first I didn't. Sorry, guys. I need 1 in that spot. So what am I going to do? I'm going to multiply row 2 by 1/5. Okay. I mean, you can think of it as division, guys, but remember with matrices, usually we want to think of multiplication. I'm not going to do my side work for that because you guys should be able to do that in your head. So that gives me 0, 1, and 1. Awesome. So it is in row echelon form. It's not in reduced form, but don't worry about it. It is okay because this is easy. We know that y equals 1, right? 1y equals 1. And so when we plug that into the top, we get 1x minus 1 times 1 equals 1/2 And when we solve this out, we get x equals 3/2. So I know that our solution is 3/2, 1. Make sure your solution is in the correct order. Okay, good job. Next. Okay, this one says solve the systems of equation, put it in an augmented one, and then we are going to just do it with the row echelon. Okay, so we're just going to do what we've been doing, but of course we're not just going to do examples after examples for nothing. There might be a trick to this, so let's see. Well, first of all, I see there's variables missing everywhere, right? So what I might do in this case is I might actually, when I do my augmented matrix, is instead of going by rows, I'm going to go by columns. So let's look at our x's. I have a -1, a 2, and a 0. Then I look at my y's. I have a -2, 3, 1. Then I look at my z's. I have a 1, 0, -2. Then my equals, right? -1, 2, and 0. So you got to be careful with those zeros. All right, next thing. Well, if I need x to be 1 here, what am I going to do with it? I'm going to multiply it by -1. So I'm going to multiply row 1 by -1. So I get 1, 2, -1, 1. Fill in the rest. All right, perfect. Now what? Well, I need this to be 0. How am I going to do that? My sidebook here. I am going to take row 2 and subtract 2 of row 1, and that will give me my 0. So row 2 is 2, 3, 0, 2, and I'm going to double the first row, so 2, 4, -2, 2. I'm going to subtract straight down because I want that 0. So 0, -1, 2, 0. All right, let's rewrite it. I get 1, 2, -1, 1. This is my new row 2, remember? So 0, -1, 2, 0. Row 3. All right, next up, what do we do? Well, if we look here, if I want 1 in this case, why don't I just swap row 1 and row 2? Because you can do that right in the middle if you need to. So the next step we're going to do is switch row 2 and row 3. Okay. So 1, 2, -1, 1. 0, -1. Oh, I'm switching, remember? Okay, and -1, 2, 0. Okay, great. Now we need this one. We need this one to be 0. Oh, look, guys, all I need to do is add row 3 to row 1, and then I get 0 in that spot, right? So row 3 is 0, -1, 2, 0, and I'm going to add row, and not 1, we're going to add row 2. So 0, 1, 2, and 0. Sorry, negative. What happens? We get zeros across the board. Okay, let's look at what that looks like. So we get zeros across the board for our new row below. Okay, what I want you to analyze here is that we're getting 0 equals 0. Does that happen? Yes, it always happens. So what we're going to do now is we're going to set, this is the one where it is infinite. So when this always happens, remember we have to think of the consistent dependent. So do you remember what we did for that? Remember we set z as our constant. So let me go back down here for a sec. So in our coordinate, we have z as the third coordinate, and we're going to make the other two based on z. So if you look at the y's, let's look at the y first. We get y minus 2z equals 0. So now we're going to solve for y. To solve for y and get it y by itself, we go y equals 2z. So that is what we put for the y coordinate. We're going to have it in terms of z's. Now we're going to do the same thing for the x coordinate right here. So we get 1x plus 2y, but instead of 2y, we're going to put that 2z in there. And then minus 1z equals 1. Okay, now let's do this out. So we get, that's 4. 4 minus 1 is 3z. So what we'll have is that x equals 1 minus 3z. And now we have that as our coordinate. So let's run through this example again to make sure we have it all. We're doing the row echelon form to get the triangle down here and the ones here. If you ever end up with 0 equals 0, it's going to be our consistent dependent. So it's going to be in terms of z. We're going to run into other issues later, but this is one example. All right, what do we got? 2 more example, guys, and then we're done. Sorry, it's taking so long. Okay, now let's do the reduced form. And remember, the reduced form allows us to have the answers straight in our matrix, okay? You only have to do the reduced form if it says it. If the directions tell you to do so, you have to do it, okay? So let's write the augmented. So 1, 1, 1, 4, 2, negative 1, negative 2, negative 1, 1, negative 2, negative 1, 1. Okay, do we like the first row? I like the first row. What are we going to do with the second? We have to get rid of that 2, so it's going to be row 2 minus 2 row 1. Okay, do our side work. I'm going to do it with you. So I have 2, negative 1, negative 2, negative 1. I'm going to multiply the first row by 2. So 2, 2, 2, 8. Subtract straight down. So 0, negative 3, negative 4, negative 9. Did I do that correct? I'm just double checking right now, guys, because I have a feeling I'm doing something wrong. No, I'm not doing anything wrong. I'm good. Okay, so let me rewrite that. 1, 1, 1, 4. Our new second row is 0, negative 3, negative 4, negative 9. Third row is still the same. Okay, now what? Well, why don't we get rid of this row right? We can get a 0 here by just saying row 3 minus row 1. So let me do my side work. Row 3 is 1, -2, -1, 1. 1, 1, 1, 4. We're going to subtract straight down. 0, -3, -2, -3. Okay, again, if you do not like subtraction, just multiply it by a negative so you can add it. 1, 1, 4, 0, -3, -4, -9. Our new row 3 is 0, -3, -2, -3. Okay, now let's divide row 2, or multiply, right? So by -1/3, row 2. Okay. I'm going to see if I can stick it here to give me more space. Okay, guys? 1, 1, 1, 4, 0, 1, 4/3. Ooh, that looks terrible. 3. Okay. Then we have 0, -3, -2, -3. All right, now we need to get a 1 right here, or a 0 right here. So we're going to multiply. So we're going to take row 3 minus 3 times row 2. Okay, do that work on the side. Let me get it so you guys can see more. So I'm going to take row 3, so 0, -3, -2, -3. Multiply row 2 by 3, so 0, 3, 4, 9. Oh, I don't. I'm going to add it, aren't I, guys? Yeah, I'm going to add it because these are different. So I'm going to add 0, 2, and 6. I'm running out of room. I hope I don't have to do any more. 1, 4/3, 3. My new row 3 is 0, 0, 2, 6. Oh, this is good, right? Because what do I have to do with the last row here? I just have to divide by 2 or multiply by 1/2, right? Okay, let's see where we get. 1, 1, 1, 4. 0, 1, 4/3, 3. 0, 0, 1, 3. Okay, so now I have it in the row echelon, but if we are to actually put it in reduced, okay, so as you can see, the first thing we need to do is get our triangle on the side. See how we went to the top left? We worked our way down. Well, when we do the other side, we're going to work our way up. So our next move right here is to get that 4/3 to be 0. Okay, how do we do that? Well, since we are changing row 2, that is going to change there. So row 2, and we are going to subtract 4/3 times row 3. You guys see that? I'm going to times row 3 by 4/3 and then be able to subtract them. So again, I'm having more of my work on the side. So 0, 1, 4/3, 3, and then I'm multiplying by 4/3 on the bottom. So 0, 0, 4/3, and then 4/3 times 3 is 4. I'm going to subtract straight down. So you get 0, 1, 0, -1. Now remember, what row was that? That was my new row 2. So I get 1, 1, 1, 4, 0, 1, 0, -1, 0, 0, 1, 3. Yes. Yay. Okay. Work your inside out on the side. So in other words, don't go here first. Go here. We need to get rid of that one. So how do we get rid of that one? Well, we want to change our row 1. So we're going to put row 1 in first, and we're going to subtract row 2. Okay, so if I do my work here, row 1, 1, 1, 1, 4, minus 1, 1, -1. So I get 1, 0, 1, 5. New row 1 is 1, 0, 1, 5, 1, or 0, 1, 0, -1, 0, 0, 1, 3. Whew! Almost done, guys. Now, how can I get 0 to be right here? Right. If I say, because we are changing row 1, if I subtract row 3 from it, I'm just going to subtract in my head, guys. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 5 minus 3 is 2. Okay, that's just me doing row 1 minus row 3 for my new row 1. Minus a 1. It should be 0 here. Thank you. So then I have 0, 1, 0, -1, 0, 0, 1, 3. Now, what is so great about this than just the echelon form? Well, guess what? This is our answer. Our x is 2, our y is -1, and our z is 3. So we don't have to substitute in if we did the reduced form. I know it's a lot of work, but that's why I want you to do the side work. Any row that you are changing, you always put it in first so you know which one to replace. Okay? Woo. One more, guys. One more. Okay. Solve the systems of equations, if possible, by writing the system as an augmented matrix and putting the augmented matrix in reduced echelon form. So you have to do both triangles, right? Okay. Of course, we're going to do this in alphabetical order. And as you can see, we have 4 by 4 there. Okay, I'm going to do my A's first. So A is 1, A is 0 in the second one, A is 3 in the third, and A is 0 in the fourth. B is 0 here, 0 here, 0 here, and 3 here. Oh, 1 here. Sorry, not 0, 1. Because there's 1 B there. What was I thinking? C, 0, 0, 1, 0. D, 0, 0, 0, 1. And then we have what it equals, which is 1, 0, 5, -1. Whew. Okay, so what do you like so far? I don't know about you, but I like that the diagonal's already there as 1. I like that there's zeros up here already. So the only 2 things that we need to get rid of are these 2 right here, these 3's. These 3's have to be 0, and that gives us a reduced form. So let's try to get rid of this 3. So we are changing the third row, and how we are changing it is we are subtracting 3 times row 1. Because if I multiply row 1 by 3, I can subtract those and get 0. I'm going to do some work down here because it looks like I'm not going to have to do as much work as before. So I have row 3 is 3, 0, 1, 0, 5. And I'm going to multiply the top row by 3. 3, 0, 0, 0, 3. And then what am I doing? I'm subtracting. 0, 0, 1, 0, 2. And that's my new row 3. Remember that, because that's why I put it first. My row 2 stays the same. And my row 3 is that new one, which is 0, 0, 1, 0, 2. My fourth one we didn't do anything with, so that stays the same. All right, so we got to get rid of the other 3. I want you guys to take a moment and see if you can write down the next rule to see if you're ready to do some practice. What row are we changing again? We're changing row 4. We need this to get to 0. So what row are we going to use to get it to 0? We're going to use row 2. What are we going to do to row 2? We're going to multiply it by 3, and then we're going to subtract them. Okay? All right, so let's bring that work down here. Row 4 is 0, 3, 0, 1, negative 1. And then we're going to multiply row 2 by 3. So 0, 3, 0, 0, 0. Nice and easy. We're going to subtract them. 0, 0, 0, 1, negative 1. So that is our new row 4. Okay, row 3 is the same. And row 4, 0, 0, 0, 1, negative 1. And we are in reduced form. So exactly what does that mean right there? Well, that means A equals 1, B equals 0, C equals 2, and D equals negative 1. Now, yes, I do think that this would have been easier to say, hey, we already know what A is, we already know what B is, let's just substitute it in and solve for that missing variable. The truth is, guys, one, they used easy numbers on purpose to show you, again, the reduced form. They also wanted to show you a 4x4 or a 4 equation system. So even though this would have been just as easy, just to substitute in and solve, you have to remember that it tells you how it wants it to be done, so you must do it that way. Organize your paper. Do not be afraid to use one piece of paper, a whole piece of paper for all your work. And like I said, divide it up to where you're kind of doing your little work to where you're doing your matrices, okay? Have fun.